So yeah, then welcome everybody here to this open software-defined off-the-vehicle community call organized by FEDERATE. So today we have got an introduction about the Autoware Foundation by Mohammad Saim Kawaya. I hope I pronounced it correct. So he's the president of the Autoware Foundation. So I would say welcome, and the stage is yours. Can you share the screen?
Sure. Great. Thanks so much, Mario, for having me here, and welcome to everybody. So nice to see you all. So I can share my screen, and I put together some slides to give you all an introduction about Autoware Foundation. So just let me know if you can see the slides.
Yes.
Okay. So as Mariam said, my name is Mohammad Zain Khwaja. I'm the president of the Autoware Foundation, and our mission in one sentence is to democratize access to physical AI. So what is the Autoware Foundation? What is it all about? We are a global physical AI institution. We are supported by over 100 members. Our members span from industry giants such as ARM, AWS, AMD, technology startups, and very advanced technology players like Tier 4, Deepline AI, Alternative Embedded, Gario, many others, and cutting-edge university AI labs like Technical University of Munich, Carnegie Mellon University, and many others. Essentially, our mission is to be able to work together to solve the most challenging frontiers of physical AI, and to do that for a variety of use cases and technologies, as you can see in this demo video. We are a non-profit entity, so the Autoware Foundation. I think there's some background noise. I said that Autoware Foundation is a non-profit entity, so we don't directly sell a product or a service. We are open and collaborative with regards to physical AI. We want to bring together the best institutions to build this technology together in the open source domain. And we are the developers and maintainers of the open source Autoware project, which has been under development for over 10 years. Our technology has been deployed worldwide in a variety of platforms. It's a frontier AI system, so it's pretty much, in my view, quite competitive to what the closed source players are doing. And it is applicable across multiple platforms and use cases, everything from autonomous buses, trucks, robotaxis, warehouse AMRs, and in the future, even being able to hopefully expand to other broader physical AI and robotics applications. That's a little bit about the Autoware Foundation. So what about our technology? So the Autoware project is available as a fully open source technology stack. It has over 13,000 GitHub stars and over 1,200 code contributors. We have published all of our technology under the Apache 2 license, which means it's permissive for both research use as well as commercial use. So you can build your products or your technologies on top of what we've done and commercialize that without a restriction. So really, it's a very powerful recipe book that you can take to market. And many of our companies have successfully built products and services on top of Autoware. It is a modular, open, and configurable full stack solution for autonomous driving. So you can take a component technology, maybe an AI model or a module for planning or mapping, or a full end-to-end AI model, or any part of the stack as you need for a specific application. It's powered by the latest innovations in end-to-end AI and World Foundation models. So we use the best of what is available in the research domain. We also do our own cutting-edge research, which we publish and share with the community. You're just seeing some of the demos of some of our latest models for end-to-end path prediction, depth estimation, object segmentation. We also have more classic rules-based technologies, which we think are important for safety. AI and end-to-end is very cool, and it's very powerful, but it's good to have some kind of heuristic physics-based safety system as well. And we believe that's very important when you're deploying these technologies in lots of cars all around the world. And as I showed in the previous video, we've deployed Autoware and Autoware systems in vehicles of all shapes and sizes in many, many parts of the world, from Far East Asia through to West Coast USA. So I wanted to take a deeper dive into the architecture of Autoware, tell you a bit more about our platform and our working groups. So as I mentioned, we have two kind of flavors of Autoware. One is which we call the classic rules-based architecture. This is more of your robotics first stack, where you take the physical AI challenge and you break it up into different modules. And this is something that Autoware has been the bedrock for many, many applications in the commercial domain. A lot of people have built the technology stacks on top of these modules that we have published in the open source domain. Broadly speaking, you start on the left-hand side where you have sensing. So Autoware can accept camera data, a laser scanner, LiDAR data, as well as radar data. And we have different drivers and interfaces for these sensors. We have perception, which is how the vehicle understands what's happening around it. Where are the other objects? What are those objects? What is the state of those objects? Is an object moving? Is it a pedestrian? Is there a traffic light? That's perception. And it can happen with computer vision or with AI-based perception as well. We have a localization layer that allows our system to understand where it is in a map. And we use a special kind of map called a high definition map, which is a lot more accurate than your typical navigation maps. And the stack creates this local world model, like where is the vehicle, what is around it? And then it goes into the planning stage, which plans a safe path through the environment to arrive at a goal, and a control layer that moves the physical actuators in the vehicle, be it a steering wheel, gas pedal, brake pedal. And this pipeline can be configured for different reference designs, as we call them, or different end use cases. So a privately owned vehicle, a robotaxi, a bus, a shuttle, a truck, a cart, you can configure this stack and tune these parameters as you need to, add sensors where you require them to be able to create a solution that you take to market for any one of these multitude of use cases. As we transition into what we call Autoware 2.0, we are going from this rules-based stack towards a more end-to-end AI-based architecture. So in this architecture, you try and use neural networks to learn as much of the driving as possible. So rather than having those hand-coded modules, you have a module here that is a learned driving module. It consumes the sensing data and it outputs the safe trajectory to reach a navigation goal. This is something that's been popularized by players like Tesla and Wave in the commercial domain, and we are working very hard to bring a true no strings attached open source version of that type of technology as well. We've just recently launched the Robotaxi working group within the Autoware Foundation to build this technology. With the learned driving, we also believe that it's important to have a safety stack or a safety system in parallel. This could be rules-based, it could be learned, it could be a combination of technologies, but essentially, you want to have a system that acts as a parallel source of truth for your end-to-end architecture. This also helps build redundancy into the technology and helps with scenarios where you may encounter a long-tail edge case or something that the learned driving system may not have encountered before. So this safety stack, which is likely going to be powered by physics-based sensors like LiDAR or radar, can help the learned driving system in those difficult scenarios, whereas learned driving is typically based on vision only. We have a concept of a safety guardian, which acts as an arbiter and takes these two outputs and decides the safest action. And the rest of the downstream is pretty similar. You have a control layer and a reference design framework. So we've tried to make everything as modular as possible and have clean interfaces between these different blocks. So very soon we'll be able to see the first reference implementations of this type of end-to-end AI-based architecture for private vehicles and ADAS applications, partial automation applications, robotaxis, and also robobuses and robotrucks going forward. So this is the kind of high-level picture that we have for Autoware Foundation. In the AI world, you start with the substrate of data, and we have a lot of open source data and data that our members donate to us. We have access to thousands and thousands of hours of driving data from all over the world. And we use that data to train various models, and we design model architectures within the Autoware Foundation layer by layer. We also leverage what exists in the state of the art, be it research or other open source projects. We take pride in designing these architectures and optimizing them. So we've done a lot of work in the last 12 months in creating our own architectures for both partial automation applications as well as full automation applications. As I said, all of our work is open, so we publish our AI models as fully open. That means you can inspect every single layer in every single part of every single model. You can see what data sets we've used to train those models, how did we process the data, what do the training scripts themselves look like, and the models themselves are just a single link that you can download. So we provide models in PyTorch format, in Onyx format, at different precisions like floating point precision or int8 precision for deployment in real vehicles. And broadly speaking, we have two types of AI drivers that we're building. One is the level 2 AI driver, which is more for near-term commercialization, driver assistance, partial automation applications like automotive ADAS, ADAS for trucks and buses. We'll be releasing the first version of this level 2 AI driver very, very soon. And we're now also building the level 4 AI end-to-end driver, which will be able to do the very sophisticated frontier AI approach for autonomous driving using things like World Foundation models, full monolithic end-to-end models, enabling a variety of applications ranging from robotaxi and automated logistics through to transport, off-road, and even low geofence robots. So this is the Autoware platform. We can think of Autoware as engineering tools, resources, models, training pipelines, and architecture to build these use cases. Think of Autoware as a recipe book and ingredients list with all the ingredients, and we give you a cake, but you can also bake your own cake and change things around. It's a very kind of high-level analogy, but for the most sophisticated AI use cases that you could think of. We're also built OpenADKit, which is the SOFI blueprint. Basically, it's our containerization framework. So in order to enable all of these different technologies to interface with each other, we wrap them in a container. And that container allows us to run the same workload on different computers, be it a CPU, a GPU, an NPU, or a safety MCU, on edge, in the cloud, or on a developer's machine. And the OpenADKit initiative is something that we've been developing quite extensively within the Autoware Foundation to break up our workloads into these containerized environments to enable both deployment across heterogeneous computer platforms, enable mixed critical orchestration of these technologies, as well as do cloud native deployment. So really having a closed loop from a model running on the edge to a developer machine, going into the cloud, doing the whole CI/CD pipeline, DevSecOps, model training, simulation, testing, virtual prototyping. So OpenADKit is the framework that allows us to seamlessly connect different workloads within Autoware and run them across a variety of hardware platforms. So that's a little bit about the kind of technology side. In terms of how we actually build this technology, the Autoware Foundation has different working groups. These working groups are tasked with developing engineering technologies related to a specific area of interest. Broadly speaking, we have three categories of working groups. One is the safety testing working group, which looks at things like safety assurance, simulation, defining the operational design domain of the system. That basically says, where is the system operable? We have the autonomous driving working groups that are building those reference designs, that are training those AI models and doing the architecture of those AI models for use cases like robotaxis, driver assistance, trucking, cargo, and off-road. And we have the software platform working groups that build the plumbing and the infrastructure and the abstraction layers for everything else on top of it to run very, very well. Within that, we have the software working group and the OpenADKit working group. And you can see how compute and sensing and middleware feed into our working groups. And we try and be as agnostic as we can on the sensing side, so we can work with any number of cameras, LiDAR scanners, radar scanners, any number of compute platforms. Up until now, we've primarily supported ROS2 as the middleware interface, but we are now branching out to support other types of middlewares as well, and moving towards more hardened safety-critical middleware applications too. So that's a little bit about the Autoware Foundation, about our technology, about our working groups, about our mission and what we're building. I would really encourage everybody in this call to consider joining the Autoware Foundation, becoming a member. These pictures on the right-hand side showcase many of the current active members of the Autoware Foundation, like Adastec, Deepen AI, Red Hat, Sophie, ARM, and many others. Autoware Foundation offers a number of different membership schemes that are suited to each stakeholder, be it a research lab, a startup, an industry player. Becoming a member really helps you build on top of Autoware to create commercial products and services. You can benefit from access to our network and marketing platforms. We host events, like you can see, this is a kind of CES showcase, and you can connect with customers, suppliers, and partners. We help facilitate those connections between different Autoware stakeholders. And most of all, being a member helps you study the future developments of Autoware, especially if you want to build your product or solution on top of Autoware. Being a member gives you a seat at the table. So Autoware Foundation is really the open source answer to what is being done in the closed source domain. We believe that open source always wins in the long term, whether that's Android for smartphones, Linux for OS in desktop machines and cloud compute. We think Autoware will be the open source solution for physical AI. So I encourage you to learn more, get in touch with us. You can email at admin@autoware.org. Visit our website at https://autoware.org. Thank you so much for listening. I'd be happy to take any questions which you may have.
Thank you very much, Zane. Impressive. So, any questions from the audience? Cover.
Yes, you mentioned that right now you support ROS2 by default, but you want to switch to different middleware frameworks. Can you maybe give more examples?
We've already looked at Zeno. We've also looked at IceOryx, and we're also looking at approaches where you don't necessarily have an explicit middleware at all, but you run kind of within a single process with shared memory. Or have some other low-level communication protocol. The motivation for that is if you want to go into the automotive world, ROS2 isn't perhaps the ideal solution. If you want to be compliant with ISO and various safety standards. So we're trying to see what other middlewares we can plug into the Autoware framework. And we're open to exploring other solutions by various players.
So just a follow-up question, because in the ROS2, there is a DDS running under the hood. So switching to more, let's say, safety-critical DDS is not a solution for the automotive industry?
No, it can be. So, for example, RTI offers a compliant auto-grade DDS-based middleware. So that could be one option for us. But if we want to try and enable any middleware provider to plug in. Up until now, like I said, Autoware has been primarily this modular robotics-based stack, and being used in a certain way. And as you go into the more automotive world, you go into larger scale deployments with commercial players. These are some of the considerations that we also have to be aware of. And so we're planning to do those transitions as well.
Okay, thank you.
Other questions from the audience? May I ask a question? So about these models, so everyone is now AI driven, it seems to be the case, or so this whole decision process. Are these models open source, and are they, you mentioned, are they on Hugging Face, or where they are, where we can find that stuff?
Yes, like I said, all of these models are open source, so I can actually run you through our repos. What's the easiest way to find them? So Maybe I can share a more concrete example with one of our repos. This is, let me just pull up my screen. This is a repo called Autoware Vision Pilot. This is designed for L2 ADAS system, but it is powered by end-to-end AI in terms of we have a chain of models that come together. And you'll notice that here there's a folder called models. And inside this folder, you will find everything related to these models. So there is a model library, for example, here, where you see all of the various models that we've worked on. You can go into the specific model of interest, see a demo video, have a get started tutorial, and download the model weights in Onyx format or PyTorch format. If you're interested in learning about the data parsing, we have data parsing folders for each of these models as well. They go into the details of how did we get data, how did we annotate or fuse that data, what was the convention that we used. And if you're interested in the components of these models themselves, you click on the model components folder, you click on the relevant model, and you can find the layers that comprise that model, whether it's a neck, a backbone, a head, a depth context layer. And then you can go into the code and see exactly what layer has what input and what output, and how does that come together to create the full architecture. So we're doing a bit of a cleanup and restructure of our repos, but for the most part, you can just visit the Autoware Foundation on GitHub, github.com/Autoware Foundation, and you can have a look at our repos. Overall, it's 13,000 stars, and we're now having a lot more repos with these AI models that power the stack. So I'll drop a link in the chat window for interested for the overall GitHub. And I'll also put a link in the chat for the repo that I just showed you in the demo, which is Autoware Vision Pilot, which is the L2 AI-powered ADAS system here.
Great, thanks. One more question about the data. You mentioned that you have a lot of data sets. Got them from your partners. Are they also available and shared with the community, or they are?
Yeah, so we most of our models have been trained on open data that is available to the community. And so, for example, I was referencing some data sources in those folders. So we not only train open models, but we train on open data sets. One company that's joined us very recently is a company called Natix. So Natix collects data from Tesla vehicles, and they have pretty much global coverage of this data. I can share my screen and show you. So the Natix vehicle fleet, there's crowdsourcing of data from Tesla cars, and we get the 5-camera input as well as the motion information from these vehicles, and we plan on using this data extensively for building our models. We also have players like Tier 4 who have collected extensive data, and which they are open sourcing for the Autoware Foundation and wider research community. But when you put that all together, it's well over thousands of hours of autonomous driving that we have at our disposal.
Great, thanks. So another hand raised, Michael.
Hello, Michael Polweber from AVL. I have a question: how you are handling testing, validation, update testing, so that you always ensure that what you're delivering fits together and no, let's say, defects are imported.
Sure, great question. We try and do all of the standard things, be it scenario testing, simulation testing. We try and use open source simulators like Carla and run various scenarios to scenario libraries. I was actually interested in looking at the AVL scenario simulator, and I reached out to someone on the website, but I haven't heard back, because I think you guys have a very good scenario simulator. So please do share that with us. We would love to try it out and integrate it. Because it seems like a great tool, and you offer, I think, some generous licensing. So please do let us know.
I can get you in contact. Yeah, I'll do.
Thank you.
Mario will send me your email, then I'll
yes, thank you.
Make the connection. But do you have some kind of a release schedule or so in the roadmap? One can see when updates are there? What are the and how is this release or this roadmap generated? Who is doing that? What's the organization or the strategy behind?
So we basically have a governance model where we have a board of directors and an executive leadership team that manage these strategic and technical efforts. And we have two committees, a strategic planning committee and a technical steering committee that are part of this whole planning effort. We are, we have done, we're doing our first LTS releases, I would say now. It's a very cutting edge technology with a lot of innovation. So for the ADAS side, we plan on doing the 1.0 release of Vision Pilot in the next couple of months. That would be the LTS release. And for the end-to-end AI stack, we aim to do, let's say, the first LTS release in about 12 months' time. Those roadmaps are not fully public yet, but we hope to publicize them soon.
But it's all done in open source, so you have no direct control over the developers. How to ensure that you can reach something? Or do you have commitments from some members on this release, or how is that working?
So being an open source project does not mean that everybody can push to main branch. People submit pull requests, there's careful code review, quality control checks, CI/CD checks, and so on and so forth. And our members contribute their own FTEs, be it engineers or project managers, safety experts. So we work together. You can think of us as a globally spread, diverse organization. And we basically work together to do these releases within each area of focus. So for the ADAS side, we have an ADAS work group, its members, its engineers that are working towards its first LTS release. Same with robotaxi and others.
So you have, let's say, some kind for a certain period of time guaranteed workforce, which you can rely on which you can rely on.
Yes, we have like the 100-member companies. They have their FTEs, and we also get a lot of interest from open contributors. Some of them are from very big companies. Some of them are individuals. Some of them are PhDs and researchers. But like I said, over 1,200 contributors have already been involved with the project. So we have a lot of people who can bring their ideas together to make this a reality.
Further questions?
There was a question by someone in the chat, where do you see your main differentiation compared to other open source projects such as Apollo Auto? So good question. From my understanding, Apollo Auto is not as actively maintained as Baidu compared to Autoware. It's mainly the Baidu project, whereas we try and be fully distributed and not have one company be the stakeholder of the project. So we are trying to make, number one, the project applicable to as many use cases as we can, with as many stakeholders as we can. Number two, I believe Apollo is basically still at the classical robotics level. They have some AI modules, but we'll be building full open source end-to-end stack, like an open source Wave style model, open source Tesla style model. I think that would be, again, a very big differentiator. The third one is getting to production. So whilst you could run Apollo on a car, we're trying to actually get some of our models to run on very small edge devices with a few int8 tops. In some cases, as low as 3 or 2 int8 tops for production. And going into a lot more safety hardening and compliance with automotive standards like ISO 26262, ISO 8800, SOTIF, and more. To try and not only make the stack functional, but make it safety compliant and production grade. So I think that's the big differentiator between our project and anything else in the open source domain. We're trying to go up the TRL levels to be something that is as close to a product as you could imagine, but still be open source.
Thank you. So Michael has raised his hand again.
Yeah, I would have two other questions. You said that you are planning to support other open source or middleware platforms. So at the moment it's a lot of ROS, but are you in contact with Eclipse SDV regarding the S-Core middleware?
We've kind of neighbors, right? So I've had chats with a few people, associated with the project, but we have not directly spoken with Eclipse S4. I think that as that project also ramps up, it may be interesting to see where possible synergies may lie.
Mm-hmm. Yeah, what would be interesting to have bring you both together. My second question is, when you're getting closer to, let's say, industrialized SOP-ready software, one of the issues is homologation, and which is different in different countries. Are you also working on open source, let's say, processes, open source tools to support that, so that it's easier to get certified or to get the allowance to drive in different European countries, US, China, Japan, you name it?
Yeah, so that's something our members take the lead on, because we have members that have vehicles and they collect data and do testing in these various jurisdictions. So they can kind of engage with local government regulators, find out what is required, and then feed that upstream. So we have stakeholders on the ground doing the driving, engaging with the various regulatory bodies, and it's something that will get better and better and better over time. And our mission is open source, so we don't try and keep anything as private. Everything should be as open as possible, and also be as commercializable as possible. So we wouldn't try and just say this is not open. That's kind of in our DNA.
Other questions? So maybe more question from my side. If you do all the safety stuff, all that would be open source, or is there some business case behind so that some of these partners say, okay, the safety stuff, that's something we want to offer as a service for OEMs who want to take over, or how this looks like?
Yes, very much so. That's also possible, because although you can do best effort in software, there's a lot of safety testing of an entire system, be it a camera module. Even a simple system for level 2 would have a camera module, a chip, and software. And so each component has to have its safety testing and system be certified, and the whole system and how it integrates with the vehicle. And building a safe and certified open source stack is a big challenge. I don't think it's really ever been done before. So we're really, trying to blaze a trail through this. And I think the whole concept of Autoware is that we try and do good engineering, but the commercial incentive lives with our members. And there are a number of member companies already that are planning on creating hardened versions of these stacks that have been fine-tuned with their own data, that have been safety certified for a specific product or platform that they want to pitch to a customer. So that is very much within the remit of what we try to enable within our memberships.
Great. So they use the baseline of the code, or did they fork and it's how this looks like if they do that?
I mean, they can fork it, they can clone it, they can do whatever they wish. The models are there, the recipe is there. Like I said, we give you the recipe books. We can say this is how much flour you need, how much sugar you need. Here's a cake as an example, and you can take that cake and put a cherry on it and call it your cake. Or you can take a bit of salt and make it your own cake, or bake it completely different. So really, it's there to stop you from reinventing the wheel, to not have you invest considerable resources into your own internal teams. You have almost 95% of a product available. All of the ingredients are there. They're fit for market. You take them and configure them and then commercialize on top of that. But whether that is a cloning, forking, that's really up to each company.
Other questions? That I may have the last one. How many vehicles are on the road which run in your stack? You know that, or?
How many vehicles?
Yeah.
Quite a few. I mean, the exact number is hard to know because we don't collect telemetry data from our stack. I can confidently say that any university that runs a self-driving car research program or vehicle is most likely running on Autoware. I'm pretty confident that any OEM that has an R&D lab doing level 4 autonomy has used Autoware in some form or fashion or is using Autoware. Some very famous self-driving car startups began on top of Autoware. I won't name which ones. Some of them have been acquired by bigger players in the space. And all of the members that are public, be it ARM, Tier 4, AWS, Red Hat, AMD, so on and so forth, rely very actively on Autoware and ARM modules. So I don't have a number like Waymo does or Cruise Automation did or others do, but it is a very popular open source solution. Definitely has been widespread in terms of adoption for R&D, and now we're starting to see much more significant adoption on production.
Great. Very interesting. Okay, additional questions from the audience?
Are you considered a teleoperator within the autonomous driving stack? So no, we designed the actual on-vehicle AI system. So a teleoperator is like a remote driver or someone that does remote intervention. Our goal is to build this stack such that you don't really need a teleoperator. That being said, some of our members build teleoperation technology to interface with Autoware, but our core expertise is on the AI models to remove the driver from the vehicle or from a remote operation center if possible. For certain applications like robotaxi, it's still safe to have someone intervene and maybe give a bit of help to the robotaxi if it's stuck. But no, we would be considered the actual autonomous driving stack itself more than a teleoperator. That's really not the core of what we're doing. We're doing the AI and the AD autonomous driving itself.
Is there a question, Yusuf? Yes, thank you. Okay. So, last chance, questions? If not, then I say thank you again, Zain, for this great introduction, what the Autoware Foundation is, how it works, so what we can get, and yeah, let's start, let's say, collaboration with the European SDV community. I think there are a lot of things where you can work together, especially as you mentioned, S-Core.
Absolutely.
Yeah. And if you can share the slides with us, would also be great. So if you can post it to the chat. And
sure.
Yeah. If there are no more questions, then I say thank you to everyone for joining, and hear us in the next Tech Talk, and we will upload the video. Okay.
Okay.
Then thank you, everybody.
Bye.
Bye.
Just
Thank you.
drop a link to the
Thank
slides
you. Bye-bye.
in the chat.
Okay.
Bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.
Bye bye.